In this section, we will talk about the zeros of polynomials. First off, the equation of a polynomial is given in the form f of x equals to a times x minus r1 times x minus r2 times x minus r3, where r1, r2, r3, etc., are the roots or the zeros of the polynomial function. So just want to make it clear that roots and zeros are both synonymous. Okay, so these are the values that make the function have a value of 0. Okay, so furthermore, what this tells you is that if r1 is a root or a 0, then x minus r1 is a factor. And then same thing for r2, r3, etc., etc. So if r1 is a 0, then x minus r1 is a factor. If r2 is a 0, then x minus r2 is a factor, and so on and so forth. Now, let f of x be a polynomial whose coefficients are real numbers. Then, if the complex number a plus bi is a 0f, then the complex conjugate a minus bi is a 0f as well. So what this means is that complex numbers or complex zeros come in conjugate pairs. Okay, and conjugate pairs are a plus bi, a minus bi. So for example, if 2 minus I is a 0, then its conjugate 2 plus I is a 0 as well. If 5 plus 4i is a 0, then 5 minus 4i is also a 0. If negative 3i is a 0, so negative 3i, we're going to write that as 0 minus 3i. Then its conjugate, which is 0 plus 3i, or just 3i, is also going to be a 0. So complex numbers or complex zeros, they always come in conjugate pairs. Now let's take a look at our first example. Find a polynomial function f of degree 3 whose coefficients are real numbers and that has zeros, negative 2 and 3 minus I. Assume the leading coefficient is 1. The leading coefficient is going to be your a value. So in this case, they're telling us that a is equal to 1. Okay, so let's first list out our zeros. So our first zero, r1, is negative 2. Our second 0, r2, is 3 minus I, but we just learned that the conjugate pairs theorem tells you that if 3 minus I is a 0, then 3 plus I will also be a 0. Now, the equation of a polynomial is in this format. So we're going to have f of x equals to a, which we said is equal to 1. So a is called the leading coefficient. So in this case, a is going to be 1, times x minus r1, which is going to be x minus negative 2, times x minus r2. Now here we got to be a little bit creative. So I'm going to use a bracket because we have this entire binomial 3 minus I, that's your r2. So we're going to have x minus parentheses 3 minus I. So that's like your x minus r1, x minus r2, and then we also have x minus 3 plus I. Okay, now we got to simplify this a little bit. So we have 1 times x minus negative 2, which becomes x plus 2. Here, the negative is going to distribute to the parentheses. So this is going to become x minus 3, and then negative times a negative is a positive I. Here, the same thing happens. The negative distributes. So we're going to get x minus 3 minus I. So because we're subtracting these, this 3 becomes a negative, and this I becomes a positive. We change the signs. Because we're subtracting, the 3 becomes a negative, the I becomes a negative. Now we have to multiply this. So when we multiply, always multiply the conjugate pairs first. It's going to make things a little bit easier. Now, you can do this a number of ways to show you, to like organize it. What I'm going to do is I'm going to make a little like box. And in the box, I'm going to put x minus 3 and I. That's going to be on this side of the box. And on this side, I'm going to put x minus 3 and minus I. Okay, and then I'm going to make these to my little boxes. And now I can just multiply. So x times x is x squared. And you know what? Let me do this in a different color. So now when I multiply, I have x times x is x squared, x times negative 3 is negative 3x, and then x times negative I is negative xi. Here I got negative 3 times x, that's a negative 3x. Negative 3 times negative 3 is positive 9, and negative 3 times I is going to be positive 3i. I have I times x, which is xi, I times negative 3, which is a negative 3i, and then I times negative I, that's a negative I squared. So you don't have to do this way. You don't have to use the box method. I'm doing it just to show you guys like in a more organized way. If you want, you can just go through and distribute. You'll get the exact same result. Okay, but I'm just going to lay these out. X minus 3 plus I, so pick one vertical, one horizontal if you're going to use the box methodology. Now we're going to simplify this. So when you simplify, first let's take a look at any terms that can be added to canceled out or added to be 0. For example, we have a positive 3i and a negative 3i. Those are going to add to 0. We have a negative xi and a positive xi. Those are going to add to 0. So what do we have left? We have x squared minus 3x plus 9 and a negative I squared. None of these are going to add to 0. Remember that I squared is negative 1. So what we essentially have is a negative negative 1, which is a positive 1. So this whole negative I squared, that actually equals to 1. So now let's combine our like terms. We have an x squared. We have a negative 3x and a negative 3x. That's a negative 6x. And then we have a positive 9 and a positive 1, which gives you a positive 10. So this whole thing is going to multiply to x squared minus 6x plus 10. And then you still have the 1 times the x plus 2. So now we have 1 times x plus 2 times x squared minus 6x plus 10. We have to do this one more time where we have to multiply. Now again, you could use just, like distribution here, or you could use a box method. I'm going to use a box method one more time. So vertically, I'm going to have x and a positive 2. And then going horizontally, I'm going to have x squared minus 6x and a plus 10. You don't have to do it this way. I'm just choosing to. Okay, so now let's go through and multiply. X times x squared, that's going to give you an x cubed. X times negative 6x, that's a negative 6x squared. X times 10, that's a 10x. 2 times x squared is 2x squared. 2 times negative 6x is negative 12x. And 2 times 10 is 20. All right, now let's combine our like terms. So we have just 1x cubed. We have a negative 6x squared and a 2x squared. That's going to give you a negative 4x squared. We have a negative 12x and a 10x. That's a negative 2x. And then finally, we have a positive 20. And this becomes our answer. So start with the zeros, list those out. We have R1 is negative 2, R2 is 3 minus I, R3 is 3 plus I. And then we're going to use this generic polynomial function, which is a times x minus r1. So x minus negative 2, that gave us x plus 2. X minus 3 minus I, that gave you x minus 3 and plus I. Both the signs changed, and so on and so forth. And then you can use a box method to multiply, or whatever method you prefer. Okay, take a look. Think of any questions you guys may have for class. Next one, find a polynomial function of degree 3 whose coefficients are real numbers and has zeros 5 and 2 plus I. So once again, I'm going to start this problem. I'm going to have R1 equals to 5, R2 equals to 2 plus I, and because this is a complex zero, its conjugate must also be a 0, which is 2 minus I. Okay, and then we are going to say that f of x is equal to a, now the leading coefficient is 1, so a has a value of 1, times x minus r1, which is x minus 5, times, I'm going to use a bracket here, we have x minus parentheses 2 plus I, and x minus parentheses 2 minus I. So that's going to, the one I don't have to write, so that's going to simplify to be x minus 5. The negative is going to distribute, so this gives you x minus 2 minus I. This negative is going to distribute, and this gives you x minus 2 plus I. And now you have to do the multiplication, which we will do in class. So so always start with the conjugate pairs. You can use a box or whatever you want to use, but we'll finish this off in class.